Student question number 11. 200 gram of hot water at 80 degrees Celsius is added to 300 gram of cold water at 10 degrees Celsius. So basically, there are two cases mentioned. There is some hot water, there is some cold water. So, symbolically, I keep cold water here, to which we are adding the hot water. We have another container in which hot water. According to the mass, I will label, okay? First one is 200 gram of hot water. The other is 300 gram of cold water. So I keep, this is 300 gram of cold water. And maybe this is 200 gram of hot water. We can take any one as the case, whichever is the one, we can take case 1 and case 2 because we are equating it at the end. This is 200, make hot water is 200 gram. This is hot water. This is 300 gram. It's a cold water. The hot water is at 80 degrees Celsius. 300 cold water is at 10 degrees Celsius. So 10 degrees is less than that of 80 degrees. So we call this is cold. Okay. Now the hot water we are pouring into the cold water. This is the work we are doing. So it will definitely be increasing. The cold water will increase its temperature while the hot water will decrease its temperature. And it will come to an intermediate temperature T, which will be more than 10 and less than 80. Yes or no, children?
Yes,
Come to
ma'am.
Yes,
case
ma'am.
1. Case
Yes,
1
ma'am.
is for the cold water. The details of cold water we are writing. Mass is given 300 gram. Case 1. So M1 I'm taking 300 gram. It's water only. So C is 4.2. Since it is in grams, it's given. Okay, now carefully look at children. In the question, they have given 4,200 joules per kg. Yes or no? And the
Yes,
mass
ma'am.
given is in gram. So no matter, we know the specific capacity of water is either 4.2 joules per gram per Kelvin, or we can write the C is equal to 4.2 into 10 raised to 3. 10 raised to 3 means 1000. That is 4,200. Now it will become this much joules per kg it will become. Now this is what they have given. So what you take is you take this one for per gram you take because the mass is in gram. You can change. Or what you do is the mass you change into kilograms. Is it fine?
Yes.
0.3 kg you can write. No, otherwise. So I'm taking the given value. I'm making but per gram I'm taking. Is it fine? Joules per gram per
Yes.
Kelvin. Okay, now the temperature, initial temperature of this one is 10 degrees Celsius. And final temperature, okay, what is asked to calculate? You see, neglecting the heat taken by the container. Calculate the final temperature of the mixture of the water. Specific capacity of water is this much. So we have to assume na ki let T be the initial. This you have to assume. Let T be the final temperature. You will assume. From there only you are writing. Okay. So the final temperature is T. Therefore, delta T1 is equal to difference in temperature of cold water is equal to which is bigger, T or 10? Capital T or 10, which is bigger?
Ma'am, T.
Capital T. So the expression will be capital T minus 10. This is the way you will be writing this much degrees Celsius. Okay. And the equation, heat energy gained by the cold water's equation. Heat energy gained. You also can write Cold water, we are going to take it is Q1, and that Q1, there I don't have space, no? So I'm writing Q1 is equal to M1 C1 delta T1, which is equal to mass is 300 gram. Specific capacity is 4.2 because we have equated it to per gram, no? Joules per gram per Kelvin into difference in temperature. You write it in the form of expression T minus 10. Yes, children. This is equation number 1. Hold it as equation number 1. Q1. Now, here we will combine them, but we go for, you will have to write under what you have written case 1, okay? So case 2, you write for the details of hot water. Mass M2, 200 gram, check it in the book, 200 gram of hot water, yeah. Which is at a temperature, specific capacity is the same, 4.2 joules per gram per Kelvin. And T2, initial temperature is 80 degrees Celsius. Delta T2, difference in temperature of case 2 is the meaning. So 80 and T, capital T, which is bigger? 80 is bigger. So the expression has to be 80 minus capital T. This much degree Celsius. So heat energy lost by hot water. U2. U2 is equal to M2 C2 delta T2. Substitute, mass is 200, 4.2. This is 80 minus capital T. This is your Q2, which is equation number 2. Now, you will combine them with the assumption according to principle of method of mixtures. Heat energy gained. Writing
Yes, ma'am.
Yes, ma'am.
1 is equal to Q2. Q1's expression, I'm writing 300 into 4.2 into T minus 10 is equal to, on the right side, we have 200 into 4.2 into 80 minus T. Okay. So many things we can cancel. What are they? 4.2, 4.2.
4.2.
Yeah. 300s, 2 zeros, and 200s, 2 zeros can be cancelled. Yes or no?
Yes, ma'am.
Yes, ma'am.
What is left, you will rewrite. Okay. This is 3. Don't forget. 3 into, we have T minus 10 is equal to, here it is 2 into 80 minus T. Can you solve now?
Yes, ma'am.
Okay.
Yes, ma'am.
3T minus 3 into 10 is 30 is equal to 2 into 8 is 160 minus 2T. Minus 2T you bring to the left side. So 3T plus 2T will become 5T is equal to 160 minus 30 goes there, it become plus 30. Yes or no?
Yes, ma'am.
5T
Yes,
is
ma'am.
equal to 190. Therefore, T is equal to 190 by 5. What is the answer? 38 degrees
38.
Celsius?
38 degrees Celsius.
Good. Here, last sentence you have to write. You have to write that is the heat and the final temperature of the mixture is 38 degrees Celsius. Dekho, more than 10 and less than 80. It is come, no?
Yes, ma'am.
Yes. Yes. Okay, move on to the next. Have you written?
Yes,
Yes,
ma'am.
ma'am.
Come on. Question number 12. Okay. Roughly, let us read the question first. The temperature of 600 gram of cold water rises by 15 degrees Celsius when 300 gram of hot water at 50 degrees Celsius is added to it. What was the initial temperature of the cold water? Work is somewhat same only. Hot water and cold
Yes.
water. Okay, what I do, children, I'm just taking the previous question in which I'm just making the modification. Is it fine? Working is,
Yes,
this is
ma'am.
what you want to understand also. You don't have to modify, you'll have to do it again. So I make this as question number 12 and the data of that we will be writing accordingly. There is a cold water and hot water situations, isn't it? Final temperature, water, but we have to
Yes,
take
ma'am.
logical manner, that's it. Mass may be different, temperature may be different. Okay, how to understand the question which diagrammatically I'm representing. Yes, Jilan. The temperature of 600 gram of cold water. So whatever is the water that we have, initially the cold water is 600 gram. We just make and assume this is 600 gram. 600 gram of cold water raises its temperature by 15 degrees Celsius. Whatever was its temperature, we are assuming let T1 or we say T be the initial temperature. We can write T1, that would be better. Let T1 be the initial temperature, which we have to calculate now. So if it was at T1 degrees Celsius, whatever it is raising up is T1 plus 15 hoga na?
Yes, ma'am.
The final temperature you will assume is this one. Isn't it? It raises by 15 degrees Celsius when 300 gram of hot water. This is 300 gram hot water at 50 degrees Celsius. This was initially at 50 degrees Celsius is added to it. So this is from 50, it will come down to 50, say it will come down to T1 plus 15. So intermediate temperature is T1 plus 15. Yes or no? The expression for the temperature to take only you need to know. So for the time being, I'm just removing all the values and we can rewrite them. The rest all only substitution portion changes. This will be changing. Who all have done this?
Mama tried it, but it was coming wrong.
Coming wrong. So carefully listen. 4.22 to same hai na, so I keep the same. But these things go wrong just because that the expression for the t that you take is wrong. है ना? Okay, इसमें
Yes,
दोनों
ma'am. मेरा भी minus में.
हाँ, अब सुनो, that's what I'm explaining. 600 gram of cold water we have, to 300 gram of hot water we have. That is the situation, no? ये 300 जो है, ये hot water है. I wrote it hot, na? This is hot and this is cold. So on adding, there will be a temperature which will be intermediate temperature, which is whatever was the T1 will be raising by 15. This is what is the question says.
Yes.
Let T1 be the temperature
Yes.
initially. It will be raised by 15 means T1 plus 15 degrees Celsius will be the final temperature. So you can simply say that this is the final temperature. Okay.
Yes, ma'am.
Ah,
Yes,
so
ma'am.
how you have to write these statements? Let T1 be the initial temperature of the cold water and its final temperature is, ये भी लिखना है, and its final temperature, therefore, since it's raising by 15 degrees Celsius, the final temperature after mixing will be T1 plus 15. ये दोनों आपने लिख के रखना है. Okay. Now you tell me mass of cold water. Let us just fill the values. Mass of cold water. बोलो.
600.
100 grams.
ये
600
diagram पे
grams.
already है, तो I'm writing now. I'm not looking into the book. Then T1 initial temperature is T1. So delta T1 directly is given 15 degree. Can you write it is directly 15 degree? Because it says jitne bhi ho. Suppose if
Yes,
it was
ma'am.
5, 15 more means 20. 20 minus 5 is 15 is the difference. The difference they have given directly. Is it okay?
Yes, ma'am.
But if you want to write the way that earlier we were doing, what we do, this is T1 and delta T1 is equal to this value T1 plus 15 minus T1, which is 15 only. Yes or no?
Yes, ma'am.
Yes,
So,
ma'am.
from the sentence, it's clear that the difference in temperature, raise in temperature is 15 degrees. So directly you can take that as the 15 degree. Is it fine? C is that
Yes,
only.
ma'am.
Heat energy gained by cold water Q1 equal to M1 C1 delta T1. So you write the expression for it. What is it? Mass 600 into 4.2 into delta T1 is 15. This is your equation number 1. Yes, children? So you go
Yes,
for the
Yes,
hot
ma'am.
water also in a similar way. Mass is 300 gram. C is this temperature. Let's now make the expression for temperature. 50 was its initial temperature, which is the higher value. From the 50, you subtract this temperature. What is that? T1 plus 15. Now this bracket on operating, it will become 50 minus T1 and it will become minus 15. Yes or no? When you change the bracket, 50 minus 15 is 35. 35 minus T1 will be the expression. Can you understand? Hello?
yes.
मैम ये फिर से समझा सकते हो?
समझा सकती हूँ. Okay. Children, आप एक imagination करो. Suppose, this is a word I'm giving suppose. Suppose this final temperature here, what I've written in the expression form, suppose it is 30 डिग्री सेल्सियस. ठीक है ना? सपोज तो ये 50 से 30 में कम होएगा ना, which means the delta
Yes,
T2
ma'am.
will be 50 minus 30. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. Now it is not 30. ये तो मैंने I asked you to suppose only. So what it should be? The instead of 30 it is T1 minus 15, isn't it? So difference in temperature
Yes.
is this 50 is the final initial temperature of the hot water minus this is the lower value than that of the 50. No, this is higher. Higher minus lower. So in bracket,
Yes,
I put
ma'am.
T1 minus 15. I put in the bracket. Is it okay? Now
Yes, ma'am.
Yes, ma'am.
bracket change करने से this minus sign will go for both of them. Yes or no? So minus T1
Yes, ma'am.
minus and minus will become plus 15. Yes or no?
Yes, ma'am.
Yes,
50
ma'am.
minus T1. ये इसके लिए minus. Now this minus will make this to plus 15. 50 plus. Yes or no?
Yes, ma'am.
Okay. Sorry, this was plus better. This plus will become minus now here. I didn't put
Yes,
put a plus in between. Earlier what I did was correct. So I'll do it again. 50 minus what is inside the bracket? T1. They put
Plus
T1 plus 15. This is T1 plus 15. Okay. This 50
yes,
minus
ma'am.
T1 plus 15. Is it clear now?
Yes, ma'am.
हाँ, अब क्या expression बनना है बोलो? 50 minus, I'm opening the bracket. This minus will go for T1. This minus and this plus, this will go here as a minus. तो दोनों में minus जाएगा ना? Now 50 minus 15 पहले करो. What is it? 35. 35 minus T1. Yes or no?
Yes, ma'am.
Yes,
Sajid, did
ma'am.
you? Okay, fine. So the delta T2 is 35. I did it. Now I need not to do it now.
Oh, ma'am.
Yes, ma'am.
Select that. I'll write it again. 50 minus T1 plus 15, which is equal to, I'm getting 35 minus T1. In bracket only you place that. When you substitute now, we will have this as a delta T2. Okay, now substitute Q2 is equal to M2 is 300 into 4.2 into 35 minus T1. Okay, now equate, solve for T1. You will get the initial temperature of water. Can you now try?
Yes, ma'am. Done.
Yes. This is your equation number 1. This is your equation number 2. Okay. T1 is 600 into 4.2 into 15 is equal to 300 into 4.2 into 35 minus T1. Okay. Cancelling or cutting. If you want directly 600 or 300 करके यहाँ पर 2 आएगा, है ना? 4.2 directly goes. 2 into 15 is equal to 35 minus T1. Therefore, T1 is equal to, tell me,
5
degrees
5.
Celsius.
30 goes there. T1 take here. It will be 35 minus 30, which is equal to 5 degrees Celsius. So initially the water was at 5 degrees Celsius. Yes or no?
Yes,
ma'am.
ma'am.
Yes. Simply एक logics जो भी बोला है that you make it as a logical answer. Come on. Now the last question. Have you all written?
Yes,
Yes, ma'am.
ma'am. Last कर ली.
Yes,
Okay. Should I do it for anyone? If you say I'll do, children.
Ma'am, I'm trying. If I didn't get, I will tell you.
It's number 13. I'm working in any way. Okay. This is 1 kg of water. 1 kilogram of water is contained in a 1.25 kilowatt kettle. Calculate the time taken for the temperature of water to rise from 25 degrees Celsius to its boiling point 100 degrees Celsius. Specific capacity of water is this much. Again, you see here, mass is given in kilogram and the specific capacity is given joules per gram. So you have to adjust them. Any one you have to change into the other's unit system. Yes, children.
Yes, ma'am.
Yes, ma'am.
And the power is in kilowatt. That also has to be made into watt. Joules per second it will become na. So given this is of a
Yes, ma'am.
kettle. Kettle. Yeah. Data values that are given, the power is given. Power is equal to 1.25 kilowatt. Immediately you change it into watt, 1000, which is equal to 1250 watt. Okay, power is equal to into 1000, na? 3 decimal places, right? So this much watt, this is the power. Then mass of water is given. Mass M is equal to, given is 1 kg, which is equal to 1000 gram. 1 second. Kilowatt, watt. Dekho, watt means 1 watt equal to joule per second. You know it, no?
Yes, ma'am.
This is in SI system. So this has to be kept in kg only, and the specific capacity we have to take it in terms of per kg format, joules per kg per Kelvin. You have to convert. Do you follow?
Yes. Yes,
Yes,
ma'am.
The system we are going to keep all in SI system. Joule is in SI system, na? What? Okay. So the 1 kg is 1.0 kg. It's same only. 1 kg. I write it's 1.0. Yeah. 1.0 means 1 only. The mass is this much. Time taken, we have to calculate what is the time taken, and specific capacity C is equal to, because what is given is joules per gram. You have to make it into 4.2 joules. Hello, how will you make it into kilogram, children? 4.2 into 10 raised to 3 joules per kg. Yes,
yes, ma'am.
per Kelvin. You have written all those. Okay. Now, the heat energy is actually supplied by the kettle only. You know, power is equal to work upon time. Yes or no, children? Yesterday also we did a lot of questions. This means the heat energy. Work is equal to energy. So this is the heat energy upon time. So we will use the equation power is equal to heat energy Q. Heat energy over time. The heat energy is equal to Q. P is equal to heat energy is Q upon time. Now, Q expression is, what is Q is equal to? MC delta T. Yes or no? In the data,
Yes.
you have to also mention it was initially at 25 degrees Celsius. That also you have to mention. Your T1 is equal to 25 degrees Celsius. And T2, final temperature is 100 degrees Celsius. They have said no. Therefore, delta T, difference in temperature is 100 minus 25, which is equal to 75 degrees Celsius. Got it?
Yes, ma'am.
Now solve and get.
Yes, ma'am.
Everything else is done. Only substitute and get the values. Q is equal to MC delta T by time.
Yes, ma'am.
252 seconds.
So that divide by 60 in order to get it in minutes and seconds, which is equal to MC delta T over time. Children, there is temperature also is there now. So write the time in full word. Power is 1250 watt is equal to mass is 1 kg. Specific capacity we have converted into per kg. This is per kg. Yeah. 4.2 into 10 raised to 3 joules per kg per Kelvin. Delta T is 75 divided by the time. Can you solve?
Yes, ma'am.
1 into 4.2 into 10 raised to 3 into 75 divided by 1250. First you obtain it in seconds, no? Joules per second, what we have taken, not the second, the time we are getting. Then divide the seconds into, divide by 60 in order to make it into minutes. — 252 seconds now.
Yes, ma'am.
Should I cut or you do? 2,
Ma'am,
yeah. It's not that difficult. 252 seconds. Which is equal to, what do you do, children? 60 seconds, 1 minute, no? So you will divide 252 with 60. If you don't know, how will you do 252 with 60? This way also you can do. if you can. If not, what do you do? You first write divide by 60 and 1 decimal place for both of them you keep. Do you understand?
Yes, ma'am.
With 10 you divide basically. So 25.2 divided by 6 you solve. 25.2.
4.2.
That is, but now you want to obtain it in the form of seconds, then the whole of the 252 you want to do. It's not a numeric value we are getting. We are making it into minutes and the remaining seconds. So exact 252, how many 60s are there you are checking basically. Okay. 4, 4 6 are 24 na.
Yes, ma'am.
जो
Yes.
बचा that is 12 seconds बच गया. So 4 minutes and 12 seconds will be the answer. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes.